Okay, so I wanted to talk about how to take a generic API and wrap it in a more domain-specific API, the refactorings you can use for that. In working with Atomic Jolt, I know there's been a lot of XML work done. I saw Cami was doing a lot with XML. And Nokogiri exposes a wonderful API for manipulating and querying XML. It's really, really nice, but it's also very general. And so when you're needing to query the same sorts of things over and over, you wind up duplicating yourself, or you wind up creating a set of functions that just kind of get scattered everywhere. So we're going to talk about how you can make that cleaner. We're going to depend on object try, which Rails gives you, but vanilla Ruby doesn't. So this is just like the bare minimum implementation of object try, just so there's a baseline of what we're talking about. When you call object try, it basically calls the method you're asking for, unless the object is nil, in which case it returns nil. That's all this does. Okay, so we're going to say we're going to have this XML file of genealogical data, and we're going to want to try and query it. It's just got different people in here, and at the bottom it's got a definition of a family. This is not any sort of standard XML format. I just made this up for the purpose of demonstration. But like a simplistic implementation would probably look like this, right? We open the XML file. We look for the person record with the ID we want. We look for the name full element in there, so name full. And we print that, or try to, assuming it exists. And then the same with a death date. We look for the death event and the date, and we print it. So again, there's nothing wrong with this. It only becomes wrong when you start doing this over and over and over again, and you don't want to keep saying person at name full everywhere you're getting a person's name, right? As far as APIs go, like I said, Nokogiri does an excellent job. This is a great API. But for a specific domain, we can do better. One way, well, first let me just demonstrate. If we run this, the raw API, you'll see it pulls that name and death date out of the file. So one way to clean this up is to extract them to functions, right? We see this a lot. You'll find that you're doing a certain thing over and over again, like getting a person's name. So to reduce the duplication, you pull that out into a function, and then you have this, which that's a lot better, right? It's a lot cleaner. It's a lot more intention revealing. One of the issues with, where'd my cursor go? One of the issues with this is that you're mixing too many concerns. You're talking about parsing the XML file, and you're talking about interpreting the XML data. And you're doing it all at once. So like I said, in little chunks, it's not a big deal, but as your scope grows, that's going to be harder to maintain. You want to separate the parsing from the semantic interpretation of the data. So really, who wants to think about the format of an XML file every time you're trying to get data out of it? It'd be nice just to, in one swoop. Oh, you would. He's not kidding. So this does better, right? This at least takes the semantic part and separates it from the parsing part. So now when we're actually using the data, we can say person name, person death, and so on. But what if we could do this, right? What if we could encapsulate that data file in something very domain specific? Like we're going to deal with a genealogy tree. And then when we have that tree, we can find the person. And once we have the person, we can get their name and the full name out of it, and the death and the date. This is a lot cleaner. Like this is a lot more object-oriented. It's a lot more flexible. You could pass just the name object to something, right? And query and manipulate just the name like separately from the person. It's just a lot cleaner. So let's go through a few steps to see how we can get to this API. The first thing we might try is just creating a class for each one. This is the most straightforward approach, right? We have a factory method that takes the file and reads it, and then another factory method that parses the XML and passes that to Nokogiri. And then we have our initialize, which takes the actual document, right? So our tree wraps that node, and then we do operations on it, like finding a person. Person wraps a node, and then we can query the name and event. We have shortcuts for birth and death here. And name wraps the node, and then we have operations that work on that node. Event wraps the node, and then we have some operations that work on that node. And this works great. Like, we can come in here and run our domain API now, and again, we get the information we want out of it. It's a lot clearer. It's testable. We could write tests about this, right? Make sure we're querying the name correctly. And once we know that that's correct, anytime we query a name, it will be correct. So there's lots of benefits there. Drawback of this approach is this. We're doing this everywhere, right? Every class is wrapping that node and doing something with the node. Now we could have a superclass that's like genealogy object or node wrapper or something, which encapsulates that, and then everything else inherits from it. But that's kind of a false inheritance. We don't want to inherit just because they all happen to have in common that they initialize based on the node. So another option is to use Ruby's Delegate library. I don't know if anyone here has ever used the Delegate library from Ruby, but it's kind of slick. It exposes a class called Simple Delegator, and you can inherit from it. And then you can wrap any object. So here we have our wrapper. We wrap the hello world string. We can call the length on it, just because it delegates that through. And we can put custom functions, methods, on our delegate there. So we can encrypt things. We run this. And sure enough, we get the length of the string, and we get that strongly encrypted text.
So what does Delegate do?
Basically, like here we're inheriting from Simple Delegator. So what it gives you is an initializer that accepts an object. And then any method that the subclass doesn't recognize, it automatically delegates to the object you pass in here. Okay? So in this case, length, which is not defined in our subclass, gets delegated to the string. Encrypt, which is recognized, gets called here. TR, which is a method of string, gets delegated because it's not recognized here. Okay? So that's kind of a nice pattern. We have all of our things now inherit from Simple Delegator, tree, and person, and name, and event, and that gets rid of the initialize, and it gets rid of the node. And now we can use our tree instance. If we look at our domain API, we can use this and our person instance as if it were a Nokogiri node. Because anything we send to it that it doesn't recognize is just going to get passed through the node. So we can do custom one-off XML queries without having to do anything else. We get it for free. That's pretty cool. So let's try that. Let's try our take two. Prove that it's working. There we have it. We get the person's name and their date from that. But it's still not perfect. Remember here when I was saying, well, we could create a superclass that just wraps the node. That's really all we've done with this delegate, is create a superclass that wraps the node and gives us some other functionality. Also, delegates, there's a lot of magic there. If I have a function that expects a string and I pass it this, is it guaranteed to work? Like, will it for sure not get goofed up because it's a delegate, not an actual string? There's a lot of mental overhead, a lot of complication that just kind of interferes with your ability to think clearly about what it's doing and what's going on. So delegates are nice, and it is really nice that they give us that direct access to the node, right, so that we can make those queries. But it'd be nice if we could do it without that middleman, without the delegate that's standing in the middle. Okay, so that was the delegator. So we can do it with modules. Modules are the way that you do this sort of thing in Ruby. We can create a module here, for instance. It just adds a method, hiccup. We can create an object and extend that instance. I mean, we use modules a lot for extending classes, right? But you can do them to extend actual object instances as well. So here we're extending this object instance with A, and then we can call hiccup right there. Ta-da! So yeah, there's nothing up this sleeve, nothing up this sleeve. So what if we make our person and our tree and our name and our event, make those all modules, and just extend a Nokogiri node directly. We wind up with something like this. So we have our modules now instead of classes, and we still have our factory methods. But notice that the from XML, instead of calling new, it just calls extend self on the Nokogiri node that we get. So this gives you back a Nokogiri node directly, not wrapped, not encapsulated, the node itself. But we're extending it with this functionality. So now the node itself has a method called findPerson on it, which lets us call at, which is a method of the node. If the person is found, we extend that person node that came back with our person module. Okay? Name. When we get the name, if there happens to be a name, we extend it with the name module. We extend the event with the event module. And everything else just works. We're not dealing with delegates. We're not dealing with separate methods. There's no magic. This is Ruby at its most fundamental. So let's come back to our domain API and demonstrate that once again, I'm not making any of this up. Oops, no, I didn't want to do that. I wanted to do that. And once again, we get the person's name and their death date back. And again, to me, this is like the epitome of elegance in Ruby, is being able to extend objects directly. There's a pattern I've used along these lines where, let's say, let me make this Ruby. You've got a begin that raises something and you rescue it. Okay? If this is raised deep down in the call tree, the call stack, sometimes you want to pass not just the exception, but some information about it back. Using just Ruby by itself, you can pass a string back with an exception, right? But with modules, let's just create a simple one here. Module extra info. And we'll just keep it really simple. We'll say we're going to put a username on here. So down here, if something goes wrong, we can instantiate an exception. Well, let's just say standard error. New something broke, and then extend it with extra info. Now our exception also accepts a username. Okay, and then we can raise that exception. Then where that is caught, we can come in here and say, well, right? We can now annotate our exceptions with information, which can help in debugging, error reporting, things like that. Just exception modules, using modules to extend individual objects is a really powerful pattern that I think works really well for a lot of different areas. It works really well for creating a domain-specific API around a more generic API. Like I said, there's nothing wrong with the Nokogiri API. It's fantastic. But when you're dealing with a specific domain, sometimes you want an API that's a bit more intuitive to use.